Start.
Good evening to everyone who's viewing this video. I'm Siddharth from Project Green Carbon and I'm going to explain what is our goal and how we plan to do it. Next slide, please. Today's agenda, the problem that we are currently facing, and the various methods that we use, the green carbon way, materials needed, functioning, and the ending summary. Next slide, please. The problem. Now, if you know anything, the problem is that we are having too much CO2 emissions, like by a lot. If you ever compare the CO2 emissions emitted by year and compare it to the human, if you compare it to the human kilo number, total kilograms, you get 64 is to 1. 64 is the amount, 64 is the number of times CO2 is but into the number of human beings total calculated kilo average tons are. Now, if you ever live in an urban city, you'll know what's the issue with carbon dioxide emission and how it's so hard to control the carbon footprint. And and also, as you know, you have seen many of your friends coughing and having asthma attacks. This is all due to the one player that is in our air, CO2. And now, as we have been trying to find this, many scientists have come up ways to dispose carbonic oxides and make very useful ways for them. A few examples have been given. Next slide, please. Using liquefied gallium, the most expensive approach that we have ever seen for carbon capture. Gallium is a very soft metal, if you know. It's very easy to twist and freeze. It's like almost it's like almost sodium, but it doesn't react much. Its melting point is just about like 30 degrees, like a bit above the room temperature. Now, if how to carbon capture, how to like if you want to capture it, you have a very simple method. In a test tube, we keep the liquid gallium. Then we inject the carbon dioxide into the liquid metal. Then, when they react, CO2 and liquefied gallium, oxygen and the most prized element that's formed is element carbon is formed. Now, if you know the price of gallium, you know that this is the the least effective approach in the cost factor, because the price of gallium per kilogram or liter is about approximately 5 lakhs as per estimates by 2019 by Sigma Aldrich. Next slide, please. Using high temperatures, the most dangerous approach that we have ever seen for carbon capture. Next slide, please. High temperature dissociates carbon dioxide into carbon and oxygen. If you know physics or basic chemistry, you'll know that high temperatures can boil or even melt strong metals, and and same thing, the high temperature can dissociate the CO2 into carbon and oxygen like the previous reaction. But the issue here is that there should be applied temperatures, which is basically artificial, and that too should be 1500 degrees Celsius. That means that the heater should heat up to 1500 degrees Celsius with a bit of change, which requires humongous amounts of electricity and energy and a lot of time to heat it up. This temperature is also like unbearable, and it's also one of the very melting points of most metals such as lead, iron, and oxygen. And if you know the melting point of iron, which is used in the heaters, it's about 1538 degrees Celsius, approximate figure, which barely, like I mean, it just bleakly surpasses our required temperature to have a high temperature dissociation of CO2. More common and cost efficient metals like tin, aluminium cannot be used as their melting point is too low, and making them again and again for the same reaction is too risky, and it requires a lot of energy rather than the latter one. Next one, please. The green carbon way. Finally, now we would like to explain what is it that the questions become. But we like to say that our method is based on the reaction between potassium hydroxide and carbon dioxide. Now, you may think that why are we using potassium hydroxide and carbon dioxide? This is a very common doubt. But if you know a very have a medium amount of chemistry knowledge, you'll know that potassium hydroxide reacts with ethanol. This forms what? Potassium ethoxide. And now this potassium ethoxide, which if it's dissolved into a solution, if it reacts with compressed CO2, can form, guess what? K2CO3, potassium carbonate, a very prized fertilizer for farmer, which can cost up to 25,000 per bag. And it produces very small amount of H2, which is negligible. Next slide, please. The materials that we need for this. The materials needed for this are pressure valves, plastic pressurized containers. We are going to have to use pressurized containers, pipes and valves, obviously, KOH, CO2 and ethanol. Next slide, please. As you can see over here, in the 1 and 2, we have they represent our potassium hydroxide and ethanol. When the valves are open, they react in the tank number labeled 3 to form potassium ethoxide and what is CO2. The CO2 is also very much negligible. Like if you calculate the number of moles that has been created, it will be like a very bleak amount. So you don't care that much. And now this water. Now you may again ask the question, why do you need water for this when it's already getting formed? If you know that potassium ethoxide is always formed in a powdery form, so this water will be able to dissolve it and turn it into a solution. This solution can then travel down the valve to reach tank number 5, where it sits there waiting for the time when the compressor finally reaches full pressure and then releases the pressure of CO2 and then allows it to react to form K2CO3, potassium carbonate and water in very bleak amount. Now you may question, what is this circle 6, 7 and 8? 8 is for letting out the solution, like the farmer needs it, right? He needs to fertilize his plants, obviously. And the 6 and 7 are refilling ones. Even our H2O tank has that. From this 6 and 7, there are valves which are open, then a fluid can be let in to fill our KOH and ethanol. Next slide, please. Complete summary. In the end, the green carbon way is always superior to all the other methods that I have mentioned before. We can actually capture the carbon that's actually being produced by many automobiles and put them to good use. We have chemically converted carbon dioxide to potassium carbonate by applying KOH and ethanol and using it as a source of potassium for the plants. We hope this project passes out as success. And we also like to, thank you.